Okay, quick video on the complex numbers, intro to complex numbers thing. If you don't have any background with these, I hope this will be a quick, give you a sense of the idea of it. We're going to do some algebra and stuff using complex numbers, which means there's an I involved, which looks like a variable. It's a letter. In a lot of ways, we treat it like a variable, but it's not really a variable. I want to start with something you know about real numbers and the number line. Multiplying by -1 gives you the opposite of things. So you could actually think of this multiplication as a rotation or flip to the other side of the number line. If I start at 4, multiplying by -1 takes me to -4. And if you start with a negative, negative times negative is positive, and you can think of that as a rotation. If you start with a negative, multiplying by -1 brings you over to the positive side. So that multiplying by -1 is this kind of a rotation halfway around the number line. It's an opposite. Well, I want to think about multiplying by I as kind of half of that rotation. Which means if you start with 1 and multiply by I, it only goes halfway there. It's not on the number line anymore. Okay, so the real numbers are in a nice line. 1 times I is going to be out here, off from the number line. Multiplying anything by I, like 2 times I, would rotate it halfway around, so out here would be 2I. And you get an axis of multiples of I going perpendicular to your number line. But the interesting thing is that I times I again brings you back onto the real number line at -1. So I times I is -1, or I squared equals -1. So that's kind of where it gets the name I, because it's called an imaginary number because it's not on your number line. But then -1 times I brings you down here to -I. That's -1 times I. And negative I times I would be back to 1. Again, negative I times I would be, well, -I squared, but I squared is -1. So we're back to +1 again, and we've come full circle on that. So multiplying by I is like a 90-degree thing, and you can keep track of powers of I that way. But the thing to remember when we're handling it is you treat it like a variable in a lot of ways, except for this fact. I squared equals -1. So I is the square root of -1. We couldn't do with real numbers. You can't do the square root of a negative. But now you can, because we just give it a name, and now we have the square root of -1. So now if I wanted the square root of -16, I could just break it up into -1 times 16, and I get I times 4, or 4I. And we have square roots of negative numbers now. At least we have a name for it, and we know how to handle them. We treat it like a variable, except that I squared is -1. So addition with these things is really easy. You can only add like terms. 3 and 5I don't add together because the 3 is real, and the 5I it's in a different direction. It's imaginary part of it. So they're unlike terms. I can't add those, but if I have another real part, I can combine the like terms and add those up, and I can combine the I terms and add those up. So that works just like it would with a variable in there. But this is a complex number. There's no real variable in there. We know what I is, and 5 plus 12I is a complex number. So adding them and subtracting them works just like terms. Multiplication's a little bit more interesting than that. So I'm going to take those same two values and do a multiplication problem so you see how this works. If you think about what you would do if this was 3 plus 5x and 2 plus 7x, is this going to come into focus for me? All right. 3 plus 5x times 2 plus 7x, you'd have to FOIL it out, and you'd have an x squared term. And right, we're going to do the same thing here. 3 times 2 is 6. 3 times 7i is 21i. 5i times 2 is 10i. And 5i times 7i is 35i squared. That's just like you would with a variable. You can combine like terms like you would with a variable. This is where it actually gets different because I know something about this. That's not just 35i squared. I squared is negative 1. So that's 35 times negative 1, or negative 35. And now I can combine the real parts and keep my 31i imaginary part. That's the result of it. Real and imaginary part together is your complex number. So multiplying these, you handle it just like you would any other algebra using your distributive property and associative property and whatnot, except whenever you see an I squared, you can replace it with negative 1 because I squared is equal to negative 1. That allows you to simplify things down. So those are the basic operations with complex numbers. Powers of I can always be worked out because I squared is negative 1, so you can work those out.